Hi, it's Mr. Luneski. Today we are looking at the last section of Unit 4. We're going to be looking at some more proofs, but today our focus is on proofs with parallel lines. So this is going to be a little kind of flashback, I guess, so to speak, of back in Unit 2 when we talked about all these angle relationships. So I'm actually going to start this video by just kind of quickly reviewing those angle relationships. If you recall, there were two different scenarios that sort of happened that we either said things were congruent, these angle relationships, or we said that they were supplementary. So I kind of just went through and listed which ones were which. Alternate interior angles were congruent, and keep in mind that that's only true when the lines are parallel. So if these lines here were parallel, these are alternate interior angles. If I had something like alternate exterior angles, I could say that those are congruent if the lines are parallel. So alternate exterior, go like that. And if I had corresponding angles, if you recall, corresponding is when they match positions. So I would say like that's in the top left corner of these four angles, and this is in the top left corner of those four angles. So corresponding, alternate exterior, alternate interior are congruent if the lines are parallel. And then finally we had that same side interior angles were supplementary if the lines were parallel. And so these two angles here and here would add up to 180 degrees if these lines were parallel. So here are some more things that we can talk about in proofs. So one of the things is that if two lines intersect to form a linear pair of congruent angles, then the linear pairs are perpendicular, meaning that if I say this is a linear pair, but I say these two angles are congruent, well, the only way that happens is if it's 90 and 90. If two lines are perpendicular, then they intersect to form four right angles. So if I tell you these two lines are perpendicular, you can assume that all four of those angles are 90 degrees. All right angles are congruent to each other, sometimes referred to as the right angle congruence theorem. If two angles form a linear pair, then they are supplementary. That is referred to as the linear pair postulate. So if you're looking at a diagram and you say two angles are supplementary, and you get it because they're a linear pair, you would use linear pair postulate. We're going to be using that quite a bit. All vertical angles are congruent, so if I have a pair of vertical angles, I can say they're congruent. That's the vertical angle theorem. We'll be using that quite a bit as well. And then just as a reminder, so at the time we used the word converse, but you really didn't know what it meant. But remember that if we are proving lines are parallel, that we use the converse theorems for the angles. Stuff like alternate interior angle converse. So let's take a look at a proof on where we might use some of this stuff. So we are given that the measure of angle 1 equals 115 degrees. We're given that the measure of angle 2 equals 65. And we want to prove that M is parallel to N. So we're proving something parallel, so this should be our reminder to use a converse. That at the end, when we say, hey, these two lines are parallel, we're going to have some angle relationship, and it's converse. So if we take a look at our proof here, angle 1 is equal to 115 and 2 is equal to 65. As always, that's our given. And let's just take a look here and see maybe where we're going with this. Always use your figure. So when I write down these numbers, well, if I add 115 to 65, that equals 180. So why am I able to just do that? We can say one of two things. We can say addition, or we can say that we're combining like terms, because both of those are constants. So CLT, combine like terms. So now, if I have 115 plus 65 equals 180, and I know that angle 1 is equal to 115, and angle 2 is equal to 65, I can do a substitution and say that angle 1 plus angle 2 equals 180, and that's a substitution. And now if I know that these two things add up to equal 180, I can say that they are supplementary. Here's a vocab word. So that's the definition of supplementary. So now the last step is, how am I able to prove that those lines are parallel? So when you get to this step, where it's the last step and it's proving lines are parallel, I want you to think about think of the angle relationship. So go back to the figure, and what's the relationship between these two angles? Well, those are consecutive interior angles. So I would use the consecutive interior converse. Anytime you're proving lines parallel, we are expecting you to write that word converse in there. Okay, let's take a look at another proof. Given that angle 1 is congruent to angle 3, prove that angle 2 is congruent to angle 4. So, in this diagram, we know that 1's congruent to 3. So that is my given. So now the next step says that 1 is congruent to 2 and 3 is congruent to 4. So if I look at 1 and 2 and I look at 3 and 4, how am I able to say that those two things are congruent? Well, 1 and 2, what's the angle relationship there? The angle relationship is that they're vertical angles. And same with 3 and 4. So I would say vertical angle theorem, or you could say vertical angles are congruent. So now finally, we're jumping down to 2 is congruent to 4. So for this, if 1 is congruent to 2, that means I can substitute. And if 3 is congruent to 4, that means I can substitute and say 2 is congruent to 4. That's a substitution. Alright, and one last proof just to kind of wrap things up here. If we're given that the measure of angle 5 is 30, and we're given that the measure of angle 6 is 150, we want to prove that M is parallel to N. Once again, we're proving something parallel, so we're going to be using a converse at some point. So, starting off, stating my given. So now the next step says that angle 4 and angle 6 are supplementary. So by looking at this diagram, how can I say that 4 and 6 are supplementary? Well, they are next to each other and form a linear pair. So you can say for this linear pair postulate, or if you want to say definition of linear pair, that's appropriate too. Because by definition of linear pair, linear pairs are supplementary. So now if I know that these two angles are supplementary, here's a vocab word. Why can I say that 4 plus 6 equals 180? That's the definition of supplementary. Remember, when we see that vocab word, we're always going to see a definition of whatever that vocab word is. So now, what's happening from this step to this step is I'm replacing 6 with 150, and that's just a substitution. And now how do I go from here to here? I subtract 150 from both sides, and that gives me that the measure of angle 4 is equal to 30, so that's our subtraction PO, or property of equality. So now back up to the diagram. As I mentioned, don't forget about the diagram. Remember that that's always there. Go ahead and fill that in. So now we know that this is equal to 30. So now the next step says that measure of angle 4 is equal to the measure of angle 5. Well, if we look back at the beginning, 5 was equal to 30, and now we're saying 4 is equal to 30. So therefore, we can say that those two things equal each other, so that would be a substitution. You probably could say transitive property for that as well. And then what's happening here? We go from equals to congruent. And remember, when we make that switch from equals to congruent, that's the definition of congruent segments. So now finally, if I know that 4 is congruent to 5, so I'm saying 4 is congruent to 5, now I'm proving these lines parallel. What's the angle relationship? Remember, think of the angles. So the angle relationship between 4 and 5 is that they are alternate exterior angles. And because we're proving lines parallel, we want to use the alternate exterior angle converse. Converse, 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 because we're proving lines parallel. Alrighty, that is all I have for you today. Thank you for watching.